Hello, good morning dear students. Welcome to digital classes under theme समय 10 से 12 वाला हर घर बने पाठशाला. This is a chemistry period and class plus 2 unit names the solid state. Today we will do the revision of whole unit. So before going to start the revision, so let's start. But dear students, before going to start, let me take this opportunity to wish you a very happy International Worker Day. Yes, it is today, 1st May. Whole world is celebrating International Worker Day or Labor Day, or also known as May Day. Okay, so on this occasion, I want to pay a tribute to say a few lines on our Corona warriors. Also, dear student, as you know, in this pandemic situation due to COVID-19, we all are safe at our home. We are locked down, but there are few people who are away from their families, not safe at their home, not taking rest like us. They are doing their duties, their job to keep us safe and trying to make a situation normal. These are our doctors, police force, medical team, and press reporter, delivery boys, and most especially the sanitizer committee, or you can say those people who are taking care of cleanliness around us. This day is devoted to them. Salute to them. Because of those people we are safe at our home. We should feel proud. हमें गर्व है. We should bless, we should pray the God may they will remain safe, and very soon the situation will become normal. So dear students, let's start with this pledge. We will stay home and we will cooperate, support our government to fight against corona. Okay, very good morning dear students. Today I'm going to revise this whole chapter, as yesterday we have finished our this unit, and we have done our last topic, that is properties of solid. So today I'm going to revise with the help of this revision map. So the chapter name is the solid state, in which a state of matter having definite shape and definite volume, that you know very well. So in this chapter particularly, we will divide this chapter into 3 parts. First part of chapter is types of solid. Second part of chapter is structure of solid. In third part of chapter we did defect and properties of solid. Okay, so as in the beginning we have done the types of solids. So there are 2 types of solids, crystalline and amorphous. As crystalline is true solids, have long range of order, and it is anisotropic in nature, and it is classified further into ionic, covalent and hydrogen bond. Okay, and molecular and metallic also. So amorphous solid, false and pseudo solid, also called supercooled liquid, and it has short range order of constituent particles and isotropic in nature. So after this, when we have done these all classification, then we came to know crystallization is how many different type of, what are the basic constituent particles. Once we have done that, suppose metallic having metals, molecular having molecules, ionic, covalent have ions, basic particles. So after that, in crystalline solids, we are talking about now crystal of structure. So structure of solids are basically, we have studied in the form of crystal lattice. What is crystal lattice? It is the complete 3-dimensional arrangement of constituent particles, and each crystal lattice is made up of small unit cell. So it is the smallest portion of the crystal lattice which on a repeating gives entire lattice. Okay, so dear students, when we studied about crystal lattice and unit cell, then we came to know unit cell is further divided into 2 parts. One is primitive unit cell, second is centered unit cell. Primitive unit cell is simple unit cell. Their atom is present only in the corner only, particles present only at the corner. Where I am using particle word, you just relate it with the atom. And how to calculate the number of atom in the particles? It is in the corner, 8 corners are there, and 1/8 part of the atom is contributing. So when we calculated it came total number of atom is participated 1, and with the radius 1/2a. Okay, so packing fraction is 52% in simple cubic. This is also known as simple cubic unit cell. And the centered unit cell is divided into 3 types basically: body centered unit cell, face centered unit cell, and one more is end centered unit cell, but there is no that much information about end centered, so we need to study in detail body centered and face centered. Okay, so body centered unit cell, 1 atom at body center along with 8 atom at corner. It means that number of atom per unit cell is 8 multiply 1/8 is 1, 1 plus 1 in center 2. Radius is under root 3/4a. Sometime 1 marks this question is asking. Packing fraction is 68%. Similar way in face centered, 1 atom at each face along with corner atom. So number of atom per unit cell is 4. How? 1/8 into 8, 1 in corner, and 3 are 6 faces are there, and each face is contributing half atom. So it is 6 multiply 1 upon 2, so total 3. So 1 plus 3 is 4. Radius is a upon 2 under root 2, and packing fraction is 74%. Okay, so like this way we have studied about the number of unit cell. Now in the structure of solid, same way we have studied about the packing. So there are closed packing of solid, 1 dimension, 2 dimension, 3 dimension we studied. In 2 dimension there are 2 types: square closed packing, hexagonal closed packing. In 3 dimension there is hexagonal closed packing and cubic closed packing. Okay, after that we have done about the between the closed packing there is the space where sphere is not there, as our cube is cubic shape and the atom is spherical shape. So obviously between the sphere there will be some gap, so that gap is known as the vacant space left in between the sphere is known as void. So it is of two type: tetrahedral void, which formed by 4 sphere, and number of tetrahedral void 2 into number of atom per unit. You need to calculate like this way. A radius of void is 0.225 radius r. Okay, and octahedral void is, it is formed by 6 sphere. Number of octahedral void, number of atom per unit cell, it is equal, and radius of void is 0.414 radius. How to calculate tetrahedral octahedral void? There is very simple. Tetrahedral void is forming in AB arrangement, and it will form in ABC arrangement. Okay, so after this when we done void, so then we were going for the third part of the chapter, that is defect and properties. So first, in defect, it is called imperfection. It is irregularities in the normal arrangement of constituent particles. Suppose there are basically, as we have done in flow chart, there are basically two type of defects. One is defect in ionic, second is defect in non-ionic. Defect is ionic is basically two types, that is, one is vacancy point defect and second is vacancy. These defect we will discuss with the help of this flow chart. Point defect is a two type: non-ionic defect and ionic defect. As non-ionic defect is vacancy defect and interstitial defect. So it is in the when some constituent particle is missing and it left some vacant, then interstitial is some particle is just misplacing or displacing from his original position and coming in between the interstitial. Whereas ionic crystal is we need to study in detail. It is of following three type: defect in stoichiometry, impurity defect, and defect in non-stoichiometry. As defect in stoichiometry is Frankel and Schottky type defect, as it is similar like vacancy and interstitial. And defect in non-stoichiometry is metal excess defect and metal deficient defect. Metal excess defect is also two type. It is anion vacancy and because of presence of extra atom, or metal deficient defect is it is cation vacancy or extra anion occupying. Third is impurity defect. It is also called doping. And after this we are talking about the properties, basic properties. So basically there are two types of properties we are studying in this solids particularly, that is electrical properties and magnetic properties. So in electric properties there are conductor, semiconductor and insulator, and in semiconductor we are studying in detail. Semiconductor is two type: N type of semiconductor and P type of semiconductor. You know very well what is N type of semiconductor. N type of semiconductor, electron rich impurities, and P type of semiconductor is electron deficient impurities. Then we have studied magnetic properties. Magnetic properties are of three types. It is diamagnetic, paramagnetic and ferromagnetic. And ferromagnetic is further divided into three parts due to its domain, that is antiferromagnetic, perimagnetic and ferromagnetism. Okay, this chapter is finished, and now I'm going to share one PDF file to you in which whole exercise is there. Let's go through that, and no need to write the questions, but you need to learn all the questions. You need to understand all the questions. Once again, whatever drawbacks is there from this chapter, let me know so that I can help you in other way also. So till then, that's it for today, and till then, take care, stay home, stay safe. Thank you. Have a nice day.